For most of history, we thought the universe made sense. Gravity pulled, stars burned, galaxies swirled. Yes, space was vast, but at least its rules seemed clear. Then in 1998, everything broke. The cosmic measurement. Two teams of astronomers set out to measure the fate of the universe. They studied type I supernovae, exploding stars so bright they act like cosmic mile markers. By measuring their light, scientists could tell how fast the universe was expanding and whether that expansion was slowing down under gravity's pull. But when the results came back, they weren't just surprising. They were impossible. The universe wasn't slowing down. It was speeding up. The impossible acceleration. Think about that. Imagine tossing a ball into the air. You expect gravity to slow it down, right? But in this case, the ball doesn't just keep rising. It accelerates upward, faster and faster, as if some invisible hand were pulling it. That's what galaxies were doing, racing away, not just moving, but accelerating. The birth of dark energy. To explain it, scientists gave this mystery a name, dark energy, not because they understood it, but because they didn't. It was as if the universe itself was infused with an unknown force, a pressure embedded in the very fabric of space, pushing everything apart. And here's the most shocking part. Whatever dark energy is, it makes up about 70% of the universe. That means most of reality is made of something we cannot see, cannot touch, and cannot explain. For the first time, humanity realized we are not living in a universe we understand. We are living in a universe dominated by something entirely alien. In Chapter 2, What Dark Energy Could Be, we'll explore the theories. Vacuum energy, hidden fields, or something stranger. A force that may decide not only the universe's expansion, but its ultimate death. When scientists discovered the accelerating universe, they were faced with an uncomfortable truth. They didn't know why it was happening, so they reached for ideas. And what they came up with are some of the boldest, strangest theories in all of physics. 1. The cosmological constant. Einstein's blunder returns. Back in 1917, Albert Einstein was struggling with his equations of general relativity. The math suggested the universe should be expanding or contracting, but everyone knew the universe was static. So Einstein added a fudge factor, the cosmological constant, a repulsive force built into space itself, balancing gravity. Years later, when Hubble discovered the expanding universe, Einstein called it his biggest blunder. But in 1998, the cosmological constant came roaring back. What if space itself has energy? A vacuum energy that pushes things apart, like an invisible pressure? If so, dark energy may not be exotic at all, just a fundamental property of the universe, hiding in plain sight. 2. Quintessence, a fifth force. Others weren't satisfied. They proposed quintessence, a dynamic energy field that changes over time. Not a fixed constant, but a fluid-like presence, ebbing and flowing across the universe. Think of it like a weather system on a cosmic scale. Sometimes calm, sometimes stormy. If quintessence exists, it means the fate of the universe isn't fixed. Dark energy could grow stronger, weaker, or even reverse. The expansion could accelerate forever, or collapse back in a big crunch. 3. Extra dimensions and exotic physics. Then come the wilder ideas. What if dark energy is the effect of hidden dimensions beyond the three we know? String theory, for example, suggests reality may have 10 or 11 dimensions. Dark energy could be the leak of gravity or energy across these hidden layers. Or perhaps dark energy is evidence of multiverses, other universes with different physics bleeding into ours, shaping expansion like ripples in a pond. It's speculation, but sometimes speculation is the first step toward discovery. 4. The terrifying possibility, phantom energy. There's also a darker scenario. What if dark energy doesn't just exist, but grows stronger over time? In this case, galaxies won't just drift apart. Stars will be ripped from galaxies, planets ripped from stars, and eventually, atoms themselves torn apart in the ultimate apocalypse, the Big Rip. If true, the universe doesn't fade into cold darkness. It ends in violent shreds. So what is dark energy? A constant? A field? A window to other universes? Or the countdown to the Big Rip? Right now, no one knows. In Chapter 3, The Fate of the Universe, we'll explore how each theory of dark energy points to a different ending. Eternal freeze, fiery collapse, or a rip through the very fabric of reality. The destiny of the cosmos depends on dark energy. And because we don't know what it is, we don't know how the story ends. But based on the theories, scientists have imagined 3 possible finales. 1. The Big Freeze, eternal darkness. If dark energy remains constant. If the cosmological constant is real, the universe will keep expanding faster and faster. Galaxies will drift apart until their light can no longer reach us. The night sky, once filled with stars, will grow emptier. In 100 billion years, only the stars of our local group will remain visible. In trillions of years, stars will burn out, leaving behind only dead embers, white dwarfs, neutron stars, and black holes. Eventually, even those will decay into nothing. The result? A dark, frozen universe. Not with a bang, but with a whisper. 2. The Big Crunch, a cosmic collapse. But if dark energy weakens, the opposite could happen. Gravity might take over again. The expansion would slow, then reverse. Galaxies would rush back together. Stars would collide. The universe would collapse into a single, fiery singularity, a mirror image of the Big Bang. This is the Big Crunch, where the end looks a lot like the beginning. Some theorists even suggest this collapse could trigger another Big Bang, a universe reborn, a cosmic cycle, infinite and eternal. 3. The Big Rip, the universe torn apart. And then there is the most terrifying possibility. What if dark energy isn't constant? What if it grows stronger without limit? In that case, the expansion of space would accelerate uncontrollably. First, galaxies would tear away from each other. Then, solar systems ripped apart. Then planets. Then molecules. And finally, atoms themselves shredded by the expansion of space. This is the Big Rip, the apocalypse not of fire or ice, but of space-time itself. If this is true, the countdown is already running. And one day, the universe will be destroyed from within. 3 endings, 3 destinies, all written by something we still don't understand. Dark energy isn't just a number in an equation. It's not just something happening out there. It is rewriting the very stage of existence. And its consequences reach right into our lives. 1. The vanishing sky. Today, step outside on a clear night. You can see the Milky Way stretching across the heavens, galaxies twinkling at the edge of vision. But in the far future, because of dark energy, those galaxies will slip away. Their light will stretch beyond detection until the night sky is nearly empty. Astronomers of the far future will look up and see nothing beyond their galaxy. No evidence of the wider universe. No proof of the Big Bang. It will be as if the cosmos itself had closed its curtains. For them, the universe will feel small. But for us, alive today, it feels endless. And that is a privilege of living now in this brief cosmic window. 2. The end of exploration. Dark energy also closes doors on humanity's dreams. If expansion keeps accelerating, galaxies will rush away faster than we could ever reach them. No matter how advanced our spacecraft, no matter how powerful our engines, the speed of light is a prison. Whole swaths of the cosmos will become forever inaccessible. Opportunities for exploration, gone before we ever had the chance. It means that if humanity wants to settle among the stars, our best chance is now, not in the distant future. The universe is shrinking in reach, even as it grows in size. 3. The existential shock. But the deepest impact isn't physical. It's philosophical. For centuries, humans have believed we could know the universe. We built telescopes, equations, and theories, convinced that the cosmos was a puzzle we could solve. But dark energy is a reminder that we are children in a vast, mysterious world. That most of the universe, 70%, is something we don't understand. As Nobel Prize-winning physicist Saul Perlmutter once said after the discovery, it's not just a little bit of the universe we don't understand. It's most of it. That should humble us, but it should also inspire us. 4. The human window. Here's the paradox. We live in the only era when galaxies are still visible, when the fingerprints of the Big Bang can still be traced, when the truth of dark energy can still be studied. Billions of years from now, intelligent beings may never know the universe was expanding. But we know. We can see it. We can tell the story. We are alive in a moment when the universe is whispering its secrets to us, before those whispers fade forever. That is the human angle. Dark energy is not just the fate of galaxies. It is the fate of our sky, our dreams, our story. In Chapter 5, The Great Unknown, we'll explore why dark energy remains the greatest mystery in physics and how the next discoveries, from space telescopes to quantum theories, may finally reveal what's tearing the universe apart. For all our progress, dark energy remains the biggest blind spot in science. We know it exists. We see its fingerprints in the expansion of galaxies. But what it actually is, that remains the greatest mystery of physics. 1. The cosmic detective work. Astronomers study dark energy not by touching it, but by watching what it does. They map galaxies across billions of light years, looking for patterns in how matter clumps together. They measure the cosmic microwave background, the afterglow of the Big Bang, for tiny ripples that reveal dark energy's effect. They track how light bends around clusters, a phenomenon called gravitational lensing. Each clue brings us closer, but the answer remains hidden. 2. The next generation of telescopes. New missions are now turning their eyes on the mystery. The James Webb Space Telescope, JWST, though famous for its images, Webb also measures faint galaxies in the early universe, testing whether dark energy has changed over time. The Euclid Space Telescope, ESA, 2023, specifically designed to map billions of galaxies. Euclid will create a 3D map of the universe to measure dark energy's push with unprecedented precision. The Vera Rubin Observatory, LSST, Chile, a ground-based telescope that will photograph the entire sky every few nights, watching how billions of galaxies shift across time. Each of these is a piece of the puzzle. 3. The quantum connection. Physicists are also chasing dark energy in theory. One candidate is vacuum energy, the energy of empty space itself. Quantum mechanics predicts that even nothing is filled with fluctuations. But here's the problem. The math predicts 10 power 120 times more energy than we actually observe. It is the most embarrassing mismatch in science, sometimes called the worst prediction in physics. Others turn to string theory and hidden dimensions or brand new forces of nature. But none fit perfectly. 4. Why it matters. This isn't just abstract science. The nature of dark energy decides the fate of the universe. If it's constant, we freeze. If it changes, we could crunch. If it grows, we rip. And solving it could unlock the next great revolution in physics, just as Newton's gravity and Einstein's relativity did before. The truth is we are still blind, but we are searching with bigger eyes, deeper maps, and better questions than ever before. In Chapter 6, Living in a Dark Energy Universe, we'll step back and ask, what does it mean to live in a cosmos where 70% is unknowable? How does this mystery reshape our philosophy, our future, and our place in the universe? For most of human history, the night sky made us feel secure. Yes, it was vast. Yes, it was mysterious. But at least it was knowable. Stars, planets, galaxies, things we could see, name, measure. Dark energy shattered that illusion. 1. The humbling lesson. Today we know that everything we can see, stars, planets, galaxies, even you and me, makes up less than 5% of the universe. The rest, about 25%, is dark matter, invisible but detectable through gravity. And about 70% is dark energy, the force ripping the cosmos apart. Which means this: the universe is not what we thought. The universe is mostly unknown. This should humble us, but should also ignite wonder. 2. A shrinking horizon. Dark energy also changes our place in time. We live in a rare cosmic window when galaxies are still visible. Billions of years from now, expansion will push them out of sight. Future astronomers may never know they existed. Think about that. We may be the only generation of beings in the entire history of the cosmos who can study the universe in its true scale. We are living in the golden age of cosmic discovery. 3. The existential shock. Dark energy also forces us to ask deeper questions. If 70% of the universe is unknown, can we ever truly understand reality? What does it mean to be intelligent in a cosmos built on mystery? Are we a temporary spark of awareness, watching the universe drift away before the lights go out? These aren't just physics questions. They are questions of meaning, questions of existence. 4. The human connection. And yet, despite its mystery, dark energy ties us to something profound. Every breath you take, every heartbeat, every moment of love, loss, joy, or wonder happens in a universe being stretched by this unseen force. We live in a universe that is alive, dynamic, restless, and though we may never fully understand it, we are part of its story. That's the real meaning of dark energy. Not just acceleration, but participation. We are witnesses to the greatest show of all time, the unfolding of the cosmos itself. So what does it mean to live in a dark energy universe? It means to live in mystery, to live in wonder, and perhaps to live in the brief, fleeting moment when the universe still reveals its secrets. In Chapter 7, the last question, we'll close with the ultimate dilemma. If dark energy controls the fate of everything, do we still have a place in the universe's story? Or are we simply passengers on a ship we can never steer? So here we are, at the edge of knowledge. We have mapped galaxies, measured the afterglow of the Big Bang, split the atom, and yet the force shaping most of reality we cannot see. Dark energy is not just physics. It is a mirror. It asks us, are we the pilots of our fate, or passengers in a universe driven by a force we cannot touch? 1. The cosmic dilemma. If dark energy is constant, we fade into eternal darkness. If it grows, we rip apart. If it changes, we may collapse in fire. None of these endings ask for our permission. The universe doesn't negotiate. And yet, here we are, the only known species that can even ask the question. 2. The human spark. Perhaps that's our place in the story. Not to stop dark energy, not to control the cosmos, but to bear witness, to know, to wonder. We are brief sparks of consciousness in a universe vast and strange. And maybe that's enough, because in the end, meaning doesn't come from the fate of the cosmos. It comes from the fact that we can look up, measure the stars, and even ask, why? 3. The call to action. So here's the last question I'll leave you with. If most of the universe is unknowable, what will you do with the part that is in your hands? Will you live small or live with cosmic perspective? Will you fight for survival or surrender to the unknown? That answer is yours. This was the dark energy mystery. What's tearing the universe apart? But the journey doesn't end here. Watch the Grey Goose scenario, when nanobots eat the world. Watch the Great Oxygen Crash, or binge the full space and apocalypse playlists. Subscribe to NetraVerse, where we turn science into story and curiosity into power. Because the universe is expanding, and so is our hunger to understand it.